So this video is going to be on determining an average. Seems kind of simple, but I thought I would give a video on this after I saw some of the solutions to a problem that was given on the Veritasium YouTube channel. And the problem that was given was, say that a person runs around a track one time with a speed of, we'll call it S1. And then he or she runs around the track again a second time, this time with a speed of S2. And the question was, how fast should the person run around the track with speed S2 so that the average speed for the whole two trips, the average speed of both time of the total time around, is actually twice speed 1. So you can go as slow as you want the first time around, and then how fast would you have to go the second time around so that the average speed is actually twice S1. So the way I think a lot of people tried to solve it was like this. They said, okay, so the average speed would be S1 plus S2, and then we're going to divide it by 2, and that has to be equal to twice S1. And we can solve for S2 to see how fast we should run the second time around the track. And if we do that, we have S1 plus S2 equals, we'll take the 2 times the other side, and that would be 4S1. And then if we solve for S2, it would be equal to 3S1. And so lots of people thought, well, you're going to have to run however fast your speed was the first time around the track, you'd have to run 3 times faster the second time so that this would all work out. So S2 would have to be 3 times your S1. And a lot of people tried to solve it and said that that was the solution. That is incorrect. That is not a correct solution, and we want to try to explain why. And to do that, we need to talk a little bit about averages and how you actually take an average. So this seems like it's supposed to be an easy thing. So if I say here are 2 numbers in a list, 10 and 16, and I say I want you to take the average, most people have been trained and taught to the way you take an average is you add up all the items in the list and you divide by the number of items in the list. So in this case, you would add 10 plus 16, you'd get 26. You divide by the number of items in the list, which is 2, and you'd get an average of 13. Now that is actually a shortcut that only works in certain situations. And I want to try to explain this. So really what you're doing, this is a shortcut here, what you're doing. So what you really do when you're taking an average is you multiply every item in the list by how much it's actually worth. So normally we assume whenever we take an average that everything is worth an equal amount. So in this case, there's 2 digits. There's only 2 digits. So we would say that each one of these things in the list is worth half of the whole. So that's because there's only 2 parts. So really when you're finding an average, you take each item times how much it's worth. So I would take 10 times how much is it worth? Well, it's worth half because there's only 2 items. Plus, then you take your next item and you take it times how much it's worth. And it would, of course, be worth 1/2 of the whole also. So there's only 2 items, so the whole, each item would be half of the entire whole. And if you do this to find the average, of course, half of 10 is 5, and half of 16 is 8, and you add them together and you get 13, which is the same answer that you got up here on this shortcut method. This looks like really the same way, because if you actually factored out the 1/2, you would have 10 plus 16. And so 10 plus 16, of course, is 26. Divided by 2 is 13. So instead of thinking about it like this, which is really the way we should think about it, a lot of people do a shortcut where they add all the items and divide by how many things there are. But really what we're doing there is we are taking each item times how much it's worth and adding all those up. So let's do another one with three different numbers in a list: 12, 27, and 18. And of course, if you did the shortcut, when everybody thinks that's how you always take the average, you'd add all three of them up. If we add all three of those up, we get 57. And we divide by the number of the items in the list, which is 3, and that is 19 as an average. So how do we really take an average? Well, the way you should always think about really taking the average is taking each item times how much it's worth. Now there's 3 items in this list, so each item would be 1/3 of the whole. So I take 12 times 1/3 plus 27 times 1/3 plus 18 times 1/3. And if you take 12 times 1/3, of course you get 4. 27 times 1/3, you get 9. And 18 times 1/3, you get 6. And if you add them all up, you get 19. So you still get the same answer. But this always seems like a shortcut. I think teachers like to teach students this way because it's really easy for them to understand, even though they might not know how they're actually figuring out the average. You're actually figuring out the average always by taking each item in the list times how much it's worth. And of course, again, you see right here, if you factor out the 1/3, you'd have a 12 plus 27 plus 18, which is 57, divided by 3 is 19. So this is how you could do it in a real shortcut kind of a method. That is all great as long as every item in the list is worth the same amount. But that's not always the case. That is not always the case. So if we take 2 numbers, let's say we take an 80 and a 90, okay? And we're going to do an average of these. And if I said take the average of these two things, let's assume these are grades. Let's say 80 is the grade that you had like in the class all year long. And 90 is what you got on like a final exam. Okay? And I said take the average of these. Well, normally everybody thinks the way you take an average is you add them together and divide by 2. So I'd take 80 plus 90, which is 170. I divide it by how many items there are, and I would get an 85. Okay? Or if I did it the proper way, I would take how much, I'd multiply each of these by how much they're worth. So 80 times 1/2 plus 90 times 1/2. Half of 80 is 40. Half of 90 is 45. And I would get 85. I'd still get the same answer, but this is a more proper way of thinking about how we're taking an average. Because what's going to happen here is most of you that are in high school at least know that your final exam and your class grade are not equal parts. They're not both worth 1/2 of the total overall grade. They're worth different percentages. We call this a weighted average, but really this is just an average. You just always need to always take the items times the amount that it's worth. So let's say that the final exam is worth 20%, which of course means the class grade is worth 80%. So how do I calculate these averages? Well, if you understand how to do the average like this, then it's actually easy. You just continue doing it like this. The key is you can no longer do this shortcut. You cannot add them together and divide by 2. You'll never get the right average. But if you do it this way, you will. So I'm going to take 80 times how much it's worth. And it's worth 80%. So that'd be a 0.8. Or you could write it as 8 over 10 if you'd like. That's 80% plus 90 times 20%, 0.2. So I see I'm still taking each item in the list times how much it's worth. 80 times 80% of 80, if you did it on a calculator, if you need to, would be a 64. And 20% of 90 would be 18. and I add those together, and I get an 82, a grade of 82. That would be the average grade in this class. So see, it's actually lower than what you would do if you had each of these half and half. Because if each of these were half and half, they were equal weight, that would mean the class is worth 50% of the grade, and the final exam would be worth 50% of the grade. Sometimes that might happen in college, but generally that doesn't happen. So the final exam is only worth 20%, and so your average grade is an 82 rather than an 85. All right, let's go back to the numbers we had earlier. We had a 12. Let's do three of them: 12, a 27, and an 18. And if I want to average those, of course, I added them all together and I divide by 3. But that's only, of course, if they're all equal weight. Let's assume they're not. Let's assume that this grade here of a 12 or whatever it is worth 50%. And 27 is worth 30%. And the 18 then, of course, would be worth how much? Well, there's 80% total there, so there'd only be 20% left. You'd still be a whole. So they would have to add up to 100 or 1. And so how do I find the average between these? Well, if I add them all up and divide by 3, I'm not going to get the right answer because they're not all worth equal amounts. They're not all worth 1/3 or 33%. They're all worth different percentages. So if you're always thinking about the average as taking the items times the amount that it's worth, that will then always work all the time when you're doing your averages. So I'm going to do 12 times 0.5 plus 27 times 0.3 plus 18 times 0.2, and I can do all those. Half of 12, or 50% of 12 is 6. 30% of 27 is a little over 8.1. And 20% of 18 is a 3.6. And if I add those all up, I would get a 17.7 would be my average between these 3 digits, because you're always supposed to take your items times the amount that it's actually worth. Okay, so if we think of averages doing it this way, instead of just adding them up and dividing by the number of items in the list, because this is actually the correct way to do it, and the other way is only if everything is worth all the same amount, but that's life isn't always quite that easy. So let's go back to our original problem and see if we can understand why maybe we got it wrong. So in this first part here, remember we went around the track with a speed of S1. That was pretty slow. And then we wanted to know how fast should we go around the second time so that the average time for all 2 times around the track, the average speed would be twice the speed around the track the first time. And what we did here is when we calculated average speed, here's where we made our mistake. What did we do? We added the 2 speeds together and we divided by 2. Why can't we do that? Well, we can't do that because they're not equal amounts. They're not 50%. Half of the time we weren't running around the track the first time, and the other half the time running around the second time, right? We were running around the track the first time a whole lot longer than the second time because we were going a lot slower in the first time. So this S1 is a much bigger percentage. So there was our mistake right there. When we try to do average, like the little trick that a lot of teachers have taught us, that doesn't always help us out because they're not equal amounts. So how can we do this? Well, another way to figure out speed is to just take the distance traveled divided by the time. A lot of you might know that easy little equation. If you drive a car, your speed is in miles per hour. It's distance per time. So distance per time is how I could figure out speed 1. Well, how far did we go? Well, we went around the track 1 time, so we can just put in a 1. We'll say one circle. And how much time did it take? Well, I don't know, but we'll call it T1. That's time to go around the track the first time. So what is speed 2? When we go around the track again, what's our speed? Well, the distance is the same. We went around 1 time, so it's still 1. But the time is going to be different, right? It's going to be actually a shorter amount of time because we're going faster. I don't know what it is, but we'll call it T2. So now we have S1 and we have S2. So now how do I find the average speed? How do I find the average speed for both times all the way around the track twice? The total average speed. Or up here, we took S1 plus S2 and divided by 2, but we can't do that. That's not right because S1 is a much larger percentage than S2 was. So the way we can find the average speed is, again, distance over time. Well, how far did we go during all the way around twice? Well, we went around 2 times. 2 times around the track. How much time did it take us to go around the track twice? Well, the first time we went around, it took us T1. Second time around, it took us T2. So the total time would be T1 plus T2. So there's my average. There's my average. So what are we trying to solve in this problem? We're saying if you take the average, we want the average to equal twice speed 1 to try to figure out how fast we need to go for speed 2. So if we take 2 times S1, which was what? It was 1 over T1. That needs to equal the average, 2 over T1 plus T2. That's the way it needs to work. So if we do that, we get 2 over T1 equals 2 over T1 plus T2. And we're trying to figure out how fast should we went around that second time. Well, the second time was T2. That's how fast, right? So what's going to make these two things be equal? Well, this is 2 over T1. This is 2 over T1 plus T2. So the only way these things are ever going to be equal is if T2 is what? Well, it'd have to be 0. We're going to have to run the second time around the track so fast that we do it in no time at all. And that is not going to happen. Even if we run the speed of light, we are not going to be able to have this T2 be 0. These two things, twice speed 1, is never going to equal the average. It's never going to happen. We cannot run the second lap fast enough so that the average is twice the speed 1. So the answer to this question actually was impossible. And the reason it was so tricky was because we don't know how to take an average. It's very important. So, hope that made somewhat sense, and you'll be taking averages correctly in the future. Take how much each item is worth times each item in the list and add them together.